This is a multiple-choice question about understanding how the length_scale parameter affects the Gaussian process regression (GPR) model with a radial basis function (RBF) kernel. I'll explain what the length_scale does and guide you through each option. It's all about how smooth or wiggly your model is. This is the core question. We need to consider how changing the length_scale impacts the GPR model's behavior. It's like tuning a dial. How much detail do you want your model to capture? Too much, and you overfit. Too little, and you miss important patterns. Let's think of the length_scale like the reach of each data point's influence. A larger length_scale means each point's influence is wider. Thus, the model becomes smoother, ignoring minor fluctuations. Conversely, a smaller length_scale means each point's influence is very localized. This makes the model more sensitive to tiny data point variations, leading to more ups and downs, higher variance. A length_scale of 0 means each point only influences itself. The model becomes extremely sensitive to each training point, resulting in overfitting, perfectly fitting the training data but failing miserably on new, unseen data. The optimal length_scale depends on the scale of your data. If one feature is measured in millimeters and another in kilometers, the length_scale would be heavily biased. You need to scale your features properly for meaningful results. This is a crucial pre-processing step. These are the possible answers to the multiple-choice question. You choose the answers that correctly describe the effects of changing the length_scale parameter. It's about testing your understanding of GPR and RBF kernels. I'm using GPR, which is gaussianprocession, with an RBF kernel, radial basis function. The RBF kernel measures similarity between data points using a distance calculation. Think of it as how much one data point influences its neighbors. The question focuses on how changing the length scale parameter affects the GPR model. The length scale controls how far apart data points must be to become essentially independent of each other. If I increase the length scale, the model becomes smoother. It's like drawing a curve with a wider brush. Individual bumps get averaged out. The model pays less attention to individual data points and focuses on overall trends. Decreasing the length scale makes the model more sensitive to individual data points. Imagine using a tiny brush to draw a curve. Every detail is emphasized. This results in more variation, or variance, in the model's predictions. It might perfectly fit the training data but perform poorly on unseen data. The best length scale depends on how spread out the input data is. If your data has features measured in meters and others in kilometers, you'll get a different optimal length scale compared to data where all features are on a similar scale. I need to scale my data for the best results. A length scale of 0 means the model only considers identical data points. This is extreme overfitting. The model perfectly matches the training data but fails miserably to predict anything outside that dataset. It's like memorizing your training data instead of learning the pattern. I'm using GPR, a machine learning method that uses Gaussian processes with a radial basis function, RBF, kernel. The RBF kernel is a way of measuring similarity between data points. It uses a parameter called lengthscale, which we'll explore further. If the lengthscale is 0, the RBF kernel only considers identical data points as similar. The model will become too complex, fitting the training data perfectly but failing to generalize to new data. Think of it like memorizing the answers instead of understanding the material. You'll do great on the exact same test, but a slightly different one will stump you. That's overfitting. The best lengthscale isn't a universal number. It really depends on how spread out your input data is. If you have features measured in centimeters and others in kilometers, you'll need to standardize your data before finding the optimal lengthscale. Otherwise, you'll misinterpret the model's behavior. Imagine fitting a line to points scattered across a country versus points in a small room. The optimal scale will be completely different. As I decrease the lengthscale, the model becomes very sensitive to minor changes in the input data, fitting the training data too closely. The model will vary significantly in its predictions depending on the input. This high variability is what we call high variance. It's like overreacting to tiny changes. Increasing the lengthscale will cause the model to be less sensitive to the individual data points. It smooths out the prediction function, averaging out small changes in the input. Think of it as taking a more relaxed approach to fitting the data instead of overreacting to every little detail. That results in a smoother curve. I'm asking you to identify the correct statements about how changing the length_scale parameter in a Gaussian process regression model with an RBF kernel affects the model's behavior. This is all about understanding how this parameter controls the model's smoothness and how it reacts to individual data points. This statement is correct. Increasing the length scale means that points farther apart will still influence each other significantly. This results in a smoother prediction curve, less affected by individual data point fluctuations. Imagine drawing a curve through scattered points. A larger length scale will create a smoother, more general fit. This is also correct. A smaller length scale makes the model highly sensitive to each data point. Even small changes in the data will drastically alter the prediction, leading to a higher variance. It's like trying to fit a complex curve through many points. The result will be highly variable and sensitive to small shifts in data. Absolutely correct. If the length scale is 0, the RBF kernel only considers identical points. This forces the model to memorize the training data perfectly, which causes serious overfitting and poor generalization to new, unseen data. You got it. The optimal length scale is heavily influenced by the scales of input features. If the features are on vastly different scales, the model won't be able to find a good length scale, and pre-processing is needed before the model can produce meaningful results. Think of it like measuring distances in meters and kilometers simultaneously. You'd need to unify those units first. I see that the abbreviation RBF stands for radial basis function. It's a type of kernel function, often used in machine learning. This specific kernel function calculates the similarity between two data points based on the distance between them. The further apart the points, the less similar they are considered. Think of it like this. Two houses close together are more alike than two houses far apart. Let's break this down. A smaller length_scale means the model becomes more sensitive to the tiny differences between nearby data points. This can lead to a very wiggly, complex model. The increased complexity means the model's predictions will vary more greatly depending on which data points it focuses on. That's a higher variance. Think of it like trying to draw a line through a bunch of closely spaced points. A short length scale means the line will be all over the place to hit every point. If the length_scale is 0, the kernel function only considers two data points similar if they are exactly the same. The model will become incredibly sensitive to the training data because it will perfectly fit every data point. It's like drawing a line that passes through every single point you have. It will look great for those points but terrible for any new points. That's overfitting. In short, 0 length scale equals an extremely complex model that won't generalize well to unseen data. The optimal length_scale changes if the scale of your input features changes. Imagine predicting house prices. If you measure house size in square meters versus square kilometers, you would need completely different length scales to get a good result. This means the length_scale value that makes the model best needs to be adjusted according to what units the data is measured in. So, we need to think about appropriate scaling, like standardizing our data, so that the length_scale can work properly. This is the core question. It asks about understanding how changing the length_scale parameter in the Gaussian process regression, GPR, model with radial basis function, RBF, kernel affects the model's behavior. I find that a larger length_scale means the model considers more points as similar even if they are far apart. This causes the model's output to become smoother because it is less affected by individual noisy data points. Think of it as drawing a line through points. A larger length scale makes for a smoother line. This question tests your understanding of how the length_scale affects a GPR model using an RBF kernel. We'll explore how this parameter controls the model's smoothness and how well it fits the data. I'll help you understand each possible effect. When you decrease the length_scale, the model becomes more sensitive to individual data points. Think of it like this. A smaller length scale means the model only pays close attention to points that are very close together. This can lead to it fitting the noise in your data. It's like it's trying too hard, resulting in high variance. Increasing the length underscore scale makes the model smoother. That's because the model considers more distant data points equally important. It's like drawing a curve through a scatter plot. A larger length scale makes the curve smoother and less affected by the jiggles of individual points. It's like connecting the dots more smoothly. A length underscore scale of 0 implies the model only considers identical data points. This forces the model to perfectly fit the training data, but that would mean it likely won't generalize well to new data. This is precisely what overfitting is. It's like memorizing the answers to a test instead of actually understanding the concepts. I'd say the best length underscore scale value depends a lot on the scales of your input features. If you have features with different scales, you'll need to make sure they're scaled appropriately to find a useful length underscore scale. It's like finding the right zoom level on a map. You wouldn't use the same zoom for viewing a city as for viewing a whole country.